Welcome. This video is on exponential equations. We're going to work on solving equations that involve exponents. Well, more specifically, the variable is in the exponents, so that's what's different here. Okay, we have this property using exponents. If b is greater than 0 and b not equal to 1, and the letters m and n are real numbers, then b to the n equals b to the m if and only if n equals m. So what that's saying right there, well, there's two things it's saying. It's saying if the bases are equal, then the exponents must be equal. Okay, so if b is the same on both sides, then the exponents have to be equal. But that if and only if, it also applies the other way around. That if those exponents are equal, then the bases have to be equal. We're not going to really worry about that right now, but whenever it's if and only if, it means it goes in both directions. Okay, don't worry about that too much right now. The important thing to know here is that if the bases are the same, then the exponents are equal to each other. All right, here's our first example. 2 to the x equals 2 to the 7th. So we want to know what x is. Well, it's not really hard to figure out what x is. What do you think? Yeah, since the bases are equal, then the exponents are equal. So that means x is equal to 7. It couldn't be anything else, right? 2 to the 3rd doesn't equal 2 to the 7th. So that x has to be the same number as the number that's in the exponent on the right, since the bases are equal. Okay, so that's probably about as easy as it gets right there. Now we just complicate things up a little bit. How about this one? 3 to the x equals 81. So can we rewrite the 81 as 3 to a power? Okay, so that's the trick here. We want to rewrite the 81 as 3 to a power. Now, maybe you could do it in your head. Maybe not. You could get your calculator out and kind of guess a little bit. Put in 3 and then an exponent, take a guess. 5. If it's too big, you try a smaller number. If it's too small, you try a bigger number. All right, and so you play around with your calculator. You might want to pause and play around with your calculator. And you should realize that it's 4. So that's the best way of doing this right now. Is just check your calculator. Is it 4? Is that what it is? Yeah. So x equals 4. Okay, again, a little bit more complicated. 2 to the x equals 1 over 8. Now that 8, can you think of the 8 as 2 to a power? Right, 3. 2 to the 3rd is 8, but it's in the denominator. Well, previously we've talked about negative exponents. So it's got to be a negative exponent that moves it to the denominator. So we can rewrite the right-hand side as 2 to the negative 3. Again, put in your calculator. Put in 2 to the power negative 3. It probably will show you 1/8 for an answer. It might put in 0.125 in a decimal, and then you could change that to a fraction. So 2 to the 3rd is 8. And then to move it up to the numerator, you make it negative. So that's 2 to the negative 3. So therefore, x is negative 3. All right, this next one, 81 over 16. And we have a 2/3 on the right. So let's try to use those same numbers, 2 and 3. How about the 81? Is it 2 to a power? No. How about 3 to a power? Yeah, 3 to the 4th. We just talked about that. And 16, is that 2 to a power? Yeah, 4. So they're both to the 4th power. So it's 3 to the 4th over 2 to the 4th, which means that we could write that in parentheses all to the 4th power. We could also switch it around and make them both negatives. Whenever you move a term from the bottom to the top or top to the bottom, the exponent changes from positive to negative or negative to positive. So in this case, positive to negative. All right, so it's 2/3 to the negative 4. You could have also done that 3/2 to the 4th and then flipped it to make it 2/3 to the negative 4. Anyway, so that should be it. Our answer is x equals -4. Plug it into your calculator. I do have videos on how to use a Casio, but whatever calculator you have, usually you can just go to YouTube, type in that model number, and you'll find videos on that calculator. All right, here we go. 16 to the x equals 8. Can you rewrite 16 with a base of 8? No, not 8 to the 2, because 8 to the second power is 64. So we're going to have to change both of them. So we could use a base of 2. So for 16, we could write it as 2 to the 4th. And for 8, we could rewrite that as 2 to the 3rd. So now the 4 and the x you're going to multiply, so that's 2 to the 4x equals 2 to the 3rd. Now we could set our two exponents equal to each other, and you get 3/4. So sometimes you have to change both bases. 16 could also be written as 4 squared, but 8 can't be written as 4 to a power, so that's why we chose 2. Because we could rewrite both numbers using a base of 2. 16 is 2 to the 4th, 8 is 2 to the 3rd. And then the rule is for exponents, x to the a raised to the b is x to the ab. So that's why we multiply 4 times x. All right, next example, example 6. Looks like the same thing, right? We could rewrite both of them with a base of 2. So let's do that. 4 is 2 squared, and 8 is 2 cubed. Okay, on the left, multiply the 2 times 3x, and on the right, multiply the 3 times x minus 1, so distribute on the right. So 2 to the 6x equals 2 to the 3x minus 3. Our bases match, so we got to match our exponents. There's our equation. Subtract 3x on both sides, so we get 3x equals -3. And then divide by 3, and you should get x equals -1. Four, 8, and 64. Same base, right? 2. I wasn't very creative with my examples here. They're all base of 2. But if you see a number like 9 or 27, you might think of a base of 3. If you see a 25, what would be your base? Yeah, 5. Okay, so 4 is 2 squared. 8 is 2 cubed. How about 64? Yeah, if you're unsure, again, just put in your calculator. Put in 2 and then the exponent button and pick a number, like 4 or 5 or 6, until you get the answer that gives you 64. All right, and then we're going to use this rule. Once we're done with that, we're going to use the rule x to the a times x to the b is x to the a plus b. So here we go. So 4 is 2 squared, 8 is 2 cubed, and 64 is 2 to the 6. So now we multiply our exponents. 2 times x is 2x. 3 times x plus 1 is 3x plus 3. Okay, now we're going to use that rule. Whenever you're multiplying the same base, but with different exponents, you add the exponents. So we're going to get 2. You don't multiply the two 2's, like 2 times 2 is 4. You don't get that. Notice above, x to the a times x to the b is x to the a plus b. So you simply write the 2 one time, and then you add the exponents. That'll give us 5x plus 3. Now we can get our equation. 5x plus 3 equals 6. Subtract 3 on both sides, and then divide by 5, 3/5. Now if you wanted to in your calculator, you could actually put an exponent of 3/5 for x and work it out, and it should give you 64. So I didn't show the check here, but you can check your answer at any time. Okay, we're going to talk about logarithms now. You may not have heard this word before. It is on your calculator. It'll say log. So you should try to find that on your calculator right now. Okay, they are important in many applications of mathematics to everyday problems, particularly in biology, engineering, economics, and social science. So there are applications. Because the number system we use is base 10, then we're going to use a logarithms with base 10. That might not mean anything right now, but you'll see. Okay, so when we have a base of 10, it's called a common logarithm. So when we say common logarithm, that means a base 10. So this notation, log x base 10, so that's how you would say that. You would say that as log of x. You could not use the word of. So log x base 10, or just simply say log x. If you just write log x, it's assumed to be a 10. You could have a different base, but for right now, the base is 10. Okay, let's use our calculator. And let's put in log of 100. So find the calculator and find that log button, and then just type in 100. Some calculators have 2 log buttons. One of them where you could type in the base. If you find that one, you just have to type in the 10. And the other one, you don't type in the base. It's assumed to be 10. You might have to hit Shift and then some other button. Like I have a Casio FX991EX right here, and where my negative button is, there's a log above it. So I have to hit Shift first and then the log. Okay, so press log and then type in 100 and then hit the equal or the enter button, and the answer should be 2. Right, hopefully you got that. I do have a video on how to use that calculator. So hopefully you could find that video. Okay, let's do another one. Before we talk about the next example, we really should talk about what that means. Why did we get an answer of 10? I'm sorry, why did we get an answer of 2? So you put in log of 100 and you got the answer of 2. What that means is that 10 to the power 2 gives us 100. So when the calculator gives us an answer, it's giving us the exponent of what it would be for 10 to give us this number. So here's our next problem. Log of 1.98. And we're going to round it to 4 decimal places. That means 4 places after the decimal. So the 5th place after the decimal, you use that number if it's 5 or more to round up, or 4 or less to round down. Okay, log of 1.98. Whatever answer we get, that means 10 to that number is going to give us 1.98, or close to it. Okay, so type it in your calculator, and you should get 0.2967. Okay, so I got 0.296665. So I'm looking at the 5th place. The 5th number is a 6, so that means we're going to round up the 6 before it to a 7. So that's why we get 0.2967. Okay, so again, what does that mean? It means 10 to that number is about 1.98. So go ahead and put in that to your calculator. Put in the exponent of, put in the base of 10. So type 10, and then your exponent button, and then 0.2967. So I'm going to do that along with you. So 10 exponent 0.2967, and I got 1.9801587808. So it's not exactly 1.98, but it's close. Remember, we did round off our answer, so that's why it's not totally exact, but it's close enough. We did have to round our answer. Okay, so that's how to use the log button on your calculator. Okay, we're going to talk about this a little bit. We're going to talk more about logs in another video. I don't want you to get too stressed out about it. This is the definition of a logarithm. So you might want to write this down. So for all positive numbers b, where b is not equal to 1, and all positive numbers r, b to the t equals r is equivalent to log of r base b equals t. All right, so in exponential form, b to the t equals r. The b stands for the base, and the t is the exponent. Logarithmic form, log of r base b equals t. Again, the t is the exponent and the b is the base. Sometimes r is referred to as the result. Okay, again, don't stress about that too much. We're just introducing it here. We'll use it more in the next lesson. So let's go back and look at this example. Log of 100 base 10. Now the calculator told us it was 2, right? Yeah. So what we're going to do is we're going to change it. Right now it's written in logarithmic form, and we're going to change it. So which number is the base? The base is 10, right? And which number is the exponent? The exponent is x, right? If you look back at your notes, the exponent was all the way on the right, and then the log of the number, that was our r. So we're going to rewrite this in exponential form. 10 to the x equals 100. And now you can see, right, 10 to what number is 100? Yes, the answer is 2. Okay, we're also going to talk about this power rule real quick, and then we're going to get into more equations. If r is a positive real number, b is also a positive real number other than 1, and p is any real number, then the log of r to the power of p, base b, is equal to p times log of r base b. All that's saying is that that power, the letter p, it goes in front of the whole logarithm. It just kind of moves all the way in front. Okay, and this is when we have a log. So whenever you have the log of something and that something has an exponent, you write the exponent in front of the log. Okay, so we're going to use this power rule. We're also going to talk about ln. It's also called the natural logarithm. So we talked about common logarithm. Common logarithm has a base of 10. Natural logarithm has a base of e, 2.718. I know, it seems a little confusing right now, right? Just hang in there. So on your calculator, you have an E button. It might have an E with a little box, or it might have what's called a caret, E with an exponent symbol, some sort of exponent symbol. And above that has ln. All right, so let's do that. So do you see the ln? The ln should be on the key itself, and then e should be above it as a second function. You might have to hit shift to get the e. All right, so let's go ahead and type in ln of 241.7. So hit ln, and then it opens up parentheses usually. It depends on your calculator. Just go ahead and type in 241.7. You should close the parentheses. And I got 5.48769. Since that's a 9, I'm going to round that up to a 7. So 5.4877. So that's the ln button. Now what that means is that e to that power gives you 241.7. Okay, so let's write this down. So ln of 241.7 equals x. So we're going to use that formula earlier. Base to the exponent equals the result. And let's put in the exponent of 5.4877. And you should get something close to 241.7. It'll be off a little bit, but that's because we rounded our answer. Okay, hang in there. It's not as hard as it seems. All right, let's just do this on our calculator. ln of 225. So hit your ln button and then 225. And I got 5.41610, so we can just leave it at that, 5.4161. So that's the main thing I want you to know right now, is just how to use your calculator, how to type in log and ln. Okay, so previously what we did is we solved equations like 3 to the x equals 81. Right, 81, that's 3 to what power? Yeah, 4. What we're now going to do is we're going to focus on equations where the bases cannot be matched, like 3 to the x equals 12. 3 to what number equals 12? Well, it's got to be more than 2, less than 3. 3 to the third is 27. 3 squared is 9, so it's somewhere between 2 and 3, and we're going to find that and round it. It's not going to be a perfect answer. We're going to have to round it to whatever the directions say. So we need another property. So this is the important property we need. And that is saying we have all these conditions. X has to be greater than 0, y greater than 0, b greater than 0, b not equal to 1. x equals y if and only if log of x equals log of y, same base. So this is also called taking the log of both sides. You know how we've said whatever you do to one side, you have to do to the other? Well, that's what we're saying here. If we put log in front of one side, we got to put log in front of the other. All right, here's what we wanted to get to. To solve equations of the form a to the x equals b. Number one, take the log of both sides. You just write log in front of both sides. Number two, we're going to use that power rule to bring the exponent in front of the logarithm. And number three, then we're going to solve it. That means get x by itself. All right, so here's our equation. 3 to the x equals 12. Step one is take the log of both sides. So put log in front of both sides. What's step two? Bring the exponent in front. So that exponent goes in front of the logarithm. All right, so that x goes right in front. So you just bring it right here in front. All right, now our next step is we want to get x by itself. So how do we get x by itself? Well, we're going to solve it by dividing by log 3 on both sides. Yeah, so what we're doing is you just put a line underneath each side, and you put log of 3 on this side, and log of 3 on this side. And now you use your handy dandy calculator to type that into your calculator. So try to hit your fraction button. I remember I do have a video on it. I'll put the link in the description. It's also on my YouTube. Anyways, you could just type in whatever. You can just type in whatever calculator you have, whatever model you have, and go on YouTube, and you're going to find tons of videos on how to do things. All right. So anyways, hit your fraction button, and then put log of 12 on top. Try to close the parentheses. If it opens up parentheses, you should close them. And on the bottom, log of 3. Okay, so you should get something like 2.261. It's a 1. We're rounding to the hundreds, so the answer would be 2.26. Okay, 5 to the x minus 3 equals 42. Very similar to the last example, only the exponent is not just x, it's x minus 3. So that'll add a couple more steps to the problem. Still the same form, a to the x equals b. So step one is to take the log of both sides. So you simply write log in front of the left side and the right side. Okay, now we're going to use the power rule. So the power rule, what that helps us do is to bring the exponent in front of the logarithm, and our exponent has a variable. That's why we want to bring that variable in front of the log. So using the power rule, we obtain x minus 3 log 5 equals log 42. Okay, now we need to solve the equation. What we're going to do is distribute on the left-hand side. A log of 5 is just a number. So if you saw a number next to parentheses and two terms in the parentheses, you would distribute that number. Well, that's what we're going to do. So distribute the log 5. So log 5 times x is x log 5. Log 5 times negative 3 is negative 3 log 5. Okay, now the constant, the one that doesn't have the variable on the left-hand side, that's a negative 3 log 5. You need to move that to the right-hand side. So when you move it to the right-hand side, it becomes a positive. So now we have x log 5 equals log 42 plus 3 log 5. Now we need to get the x by itself. So divide by log of 5 on both sides. Okay, now you could use your handy dandy calculator and you should get 5.32. And remember, that's rounded to the nearest hundredth. If you have trouble putting in your calculator, make sure when your calculator, if it opens up parentheses, like once you type in log 42, to close the parentheses after the 2. So if it opens parentheses before the 4, then you got to close it. Also try to use your fraction bar so that you put log 5 on the bottom. So the whole thing, log 42 plus 3 log 5, that has to be all in the numerators. If you're not using a fraction button, then you need to have parentheses around the whole numerator. Okay, this one's very similar to the last one. A little bit more complicated because it's got a 3 in front of the x. You should pause the video and try to work it out. Okay, same steps. Take the log of both sides. Second step, use the power rule. So the 3x minus 4 is written in front of log 2. What's next? Right, distribute. So distribute 3x times log 2 and then negative 4 times log 2. All right, good. So you have 3x log 2 minus 4 log 2 equals log 31. We need to get the x by itself. So bring the negative 4 log 2 to the right-hand side. That'll change to a positive. And now divide everything on the left except for the x. So divide both sides by 3 log 2. So that's our answer. You just need to type it into your calculator. Try to use the fraction button. I think it's easier. I do have videos on how to use a calculator, so try to check them out. But whatever calculator you have, you could just go to YouTube, type in that model number, and you'll be able to find tons of videos on that calculator. All right, I got 2.98. All right, let's move on. Okay, here's our next example. Yes, a little bit more complicated, but hang in there, we're almost there. A couple more examples after this one. Okay, this one has variables on each side. So we're still going to use our first step, take the log of both sides. All right, so we simply put log in front of the left side and the right side. Now we could use the power rule. Power rule lets us bring the exponent in front of the log. So the 3x minus 1 goes in front of the log on the left, and the x plus 2 goes in front of the log on the right. Make sure to put both of them inside parentheses. Now we're going to distribute. So on the left, that gives us 3x log 2 minus 1 log 2. If you don't want to write the 1, you don't have to. So you can just write 3x log 2 minus log 2. And on the right is x log 7 plus 2 log 7. Okay, now we're trying to get x by itself, but there's two terms that have an x. So we're going to bring the x terms to the left side. So the 3x log 2 is going to stay there, but the minus log 2 is going to move to the right-hand side. When you move a term from one side to the other, its sign will change. On the right, x log 7, we're going to move that to the left. Right now it's positive, but when you move it to the left side, it'll become negative. All right, so moving our terms, the negative x log 2, so this one went to this side, and then the x log 7 moved over to this side. All right, so that's why we got 3x log 2 minus x log 7 equals 2 log 7 plus log 2. If you have it in a different order, if you have the log 2 before the 2 log 7, it doesn't matter. Okay, now on the left side, again, there's two x's. We only want one x. Well, how can we make it look like there's only one x? Yeah, you probably didn't see this coming, but you have to factor. So on the left side, factor out an x, because both terms have an x. So x goes in front of the parentheses, and then we have 3 log 2 minus log 7. I know, it's kind of a tricky one. Okay, now divide by 3 log 2 minus log 7 on both sides to get x by itself. Now we could evaluate that using our handy-dandy calculator. And you should get 34.34. Okay, so now we need to talk about the ln. The ln still stands for a logarithm. Log, log, is called a common logarithm. It has a base of 10. Ln is still a logarithm, but its base is different. The base has an e. Okay, so the ln of e is 1. So just kind of memorize that. Ln of e equals 1. And that's because here's our reasoning. Ln base e of e equals x. If you change that from logarithmic form to exponential form, e to the x equals e. The only way that happens is if x equals 1. So the natural log of e is always going to be 1. So the examples we were doing were a to the x equals b. This is a little bit different. This is e to the x equals b. So before we were using log, we were taking the log of both sides. We're still going to do the same thing, but instead of writing log in front of both sides, we're going to write ln in front of both sides. And why is that? Because we have an e in the problem. Okay, e to the x minus 2 equals 21. Put ln in front of both sides. What happens to the exponent? Still the same thing. Same rules still apply. Power rule still applies. X minus 2 ln of e equals ln of 21. Now this is nice. We don't have to distribute like we did before, and that's because what is the ln of e? Well, there it is at the top of the screen. Ln of e is equal to 1. So it's just x minus 2 times 1. Cool, right? And what's x minus 2 times 1? Just x minus 2. So now we add 2 to both sides, and then you can type it into your handy dandy calculator. I put the parentheses there to show that probably your calculator is going to open up parentheses. You have to make sure that you always close it. So type in ln of 21 plus 2, and you should get 5.04. Yeah, it's 5.0445222438, but we're rounding to the nearest hundredth. So since it's 5.044, that 4 doesn't add it to a 5, it keeps it at a 4. All right, last problem. 3 e to the x plus 2 plus 7 equals 19. Pretty similar to the last problem, except that 7 and that 3 is different, right? Well, before we take the log of both sides, or ln of both sides, we have to get the e to the power by itself. So that means we got to get rid of the 7 and the 3. So what should we get rid of first? Yeah, let's get rid of the 7 first. So if you get rid of the 7 first, subtract 7 on both sides, that gives us 3 e to the x plus 2 equals 12, right? Yeah. Then divide by 3 on both sides. E to the x plus 2 equals 4. Now we're right back to where we were in the last example. Put ln in front of both sides. Power rule. Ln of e is equal to 1. So bring the 2 over. So it's ln of 4 minus 2. And type that into your handy dandy calculator. You should get negative 0.61. Yeah, negative 0.6137. It says hundredths, so we'll stop after the 1. The number after the 1 is a 3, so we'll leave the 1 alone. Okay, that was it. I'll see you here for the next video. Thanks a lot.